Maybe your international students never come from
All right. Well, it's Friday, so happy fourth week Friday. We are what? I guess that we're 40% through the quarter, which it always feels like, oh, well, I guess it makes sense, but also a surprise. And then like once Thanksgiving hits, it's like, oh, the quarter's over, because that's always a surprise to me. Um, well, anyway, here we are. Okay, we're talking pandas today. So again, Python, general purpose language. It was not designed around data science per se, but these two packages, NumPy and Pandas, have really extended Python's capabilities, and I would say now, Python, people love using Python for data science, and largely in part because of these two packages. And I haven't seen anything like, there's no rule against making another package for Python, but just like in R, you can like make multiple packages that do the same thing. But kind of as far as Python goes, I haven't seen anything, even remotely come close to handling any of this stuff. So Python data frames are all done through Pandas, and it's built around NumPy arrays. So in NumPy, we created the array structure, and the kind of one of the defining features of the array structure is that everything in that array has to be of the same data type, and that rapidly increases the speed of computation because Python now knows everything in this array is a float, and it can compute everything without, in a list, there's a bunch of like overhead that says, oh, this value is an integer, and this is a float, and this is a string. Everything in an array is going to be the same data type. And basically, Pandas takes arrays and it pastes them together into columns, and now we have a data frame. And so now you have this two-dimensional structure where every column is a NumPy array, and that means every value within a column is of the same data type. Okay, and so we call those columns, we call them series, and you can reference the help regarding or the reference files regarding series, and there's a whole bunch of attributes and methods and things like that. Okay, that there's a lot, but it's, again, if you're not quite sure, the reference is usually the best place to start. Okay, and then and similar, you have the reference for data frames as well, and there's a whole bunch of things to kind of read through. There's actually the examples in the data frames reference are, I think, very, very good as far as letting you know how these things work. All right, so actually let me go ahead and restart this thing. And okay, so import NumPy as NP and import Pandas as PD. That's the convention. Again, you're not required to follow convention, but you should. So one thing is, everything in Pandas, the data frames in the series run off of, there's something called an index, and that's going to power, I don't know about power, but it's kind of this, it forms like a structure for our data frames and our series. And this is one thing that is separates Pandas from R. So R has data frames and tibbles, but they don't use an index, whereas Pandas do. Okay, so to create a series, you do pd.series or pandas.series, and then you put in your data. Okay, and you can specify an index. It's optional. If you don't specify an index, it's going to use the default index, which is basically a range object of the same length. So anyway, here's my data. I got 0.25, 0.5, 0.75, 1.0. I'm going to create a series out of that. And this is what it looks like when you print a series. So 0.25, 0.5, 0.75, 1.0. And you can see it added a column over here. It's not actually, not a column. This is an index. Okay, this is an index. And your index is 0, 1, 2, 3. So that's the default index, just a range object, basically. And the values are in a series. This is basically a kind of like a NumPy array, but with an index attached. If you just ask, what does the data look like? This is what it looks like. And if you ask, what is the type? It says it is class pandas series, basically. Question?
So in a way, it's sort of like a vertical dictionary.
No, because a dictionary, you can have different data types and stuff. And so think of it as an array where you have an index attached to it. You can like subset kind of like the way you subset a dictionary and things like that, but it's not a dictionary because dictionary you can have different types and stuff. Okay, you can get the values, and so the series will have an attribute called the values, and this is a NumPy array. All right, so the values are an array, and if you ask what is the data type on this, it's a NumPy array. So Pandas series are NumPy arrays, again, with an index attached to it. So that same series, there's another attribute called the index, and the default index that it produces is basically a range object, except there's a few things that distinguish it that it's, I guess, specifically an index type object. And so when you ask what it is, it's a range index, and the type on this is it's a pandas basically index. It's a pandas index, and there's a few different types of indexes. This one's the range index, which is the default. It starts at 0, counts by whole numbers, integers up to the length. A lot of this behavior of dealing with a pandas series works exactly as you would expect. So if I say data square bracket 1, what is this going to pull out? It's going to pull out the index 1, so the second value in there, and it's going to pull out that value 0.5. Okay, and if you select only one value, it's going to simplify the object, and it's going to say, oh yeah, that's just a float. Okay, that's just a float. I guess it's a NumPy float, but yeah, it's just a floating point object. If I slice this, what is this going to return? 1:3. Okay, so because I'm selecting more than one, so I'm selecting these two values, we're going to get a series with two values in it. So this time 0.5 and 0.75, and so it's selecting these two things, and you can see it pulls out the corresponding index, right? So here, because the original series starts off at index 0, 1, 2, 3, we can see, and I've sliced it from 1 through 3, it pulls out the corresponding index 1, 2, rather than starting off at 0 again or something like that. Okay, and here, if you ask what is the type of this thing, this will say it's a series. So if you only select one value, it simplifies it. If you select multiple values, it's going to retain its series structure there. Okay. If you want, you can do what we call fancy indexing, where you can pull out, rather than saying I want, to slice from the first to the third comma or something like that, you can say I want to extract out the first, the 0 index, the index 1 again, and index 2, and so here you basically do data square bracket, and within that you provide it a NumPy array with the values that you want to extract out. Okay, so here it's going to pull out index 1, index 0, index 1, index 2, and you can pull out any sequence of values that you want to specify, and it has no problem repeating the same value again. Okay. So again, by default, if you don't specify the index, it's going to create a range index starting at 0, going up to the length. But you can also specify the index. So here, I'm going to give it an index with the values A, B, C, D. And now we have this, okay? So we have a NumPy array, 0.25, 0.5, 0.75, 1.0. Along with it is the index, okay? So the values is this array, and the index is basically, it's like an array, but it's we give it an index, it's type index, okay? And it has the values A, B, C, D, okay? If you have an index where the values in the index are, say, letters, you can subset using basically positional subsetting. So you can say data square bracket 1, and it's going to pull out the index 1, and that will be the second object in the series, as one might expect. And you can also subset using the name. So you can say, I want the value associated with the name A, and it gives you 0.25. So that's, I think that's expected. You can slice, say 0 through 2, and it will pull out the first two values. And you can slice A through C. Now, one thing about slicing via names, okay, so unlike slicing with positions, okay, so slicing with positions 0:2, it starts off at index 0, pulls out index 0, index 1, and goes up to, but does not include index 2, so it goes from A, B. Here, if I do A:C, so C corresponds to technically index 2. When you do this, it's going to pull A, B, and C. So this is something that the behavior of positional slicing and name-based slicing is a little bit different. So that's just something to be aware of. If you specify, I want to slice through index name C, it actually returns that value. Okay, and that's just how it goes. Okay. So here is a dictionary. I did the OG Avengers. Okay, and so here I have the character names and the actor that played the character, and I'm going to create a series out of this dictionary. Okay, so again, there are similarities between a series and a dictionary, but it requires that all of the data be of the same type. So you can create a series out of a dictionary, and if you do that, then the key becomes the index, and the value becomes the value in the series, right? So here, if I ask what is the index is going to be the character names, because that's what I have here, right? The character name is the key, and the value is the actor. And so here, when I ask what is the index is a bunch of character names, and the values are the actor names. Is an array of actor names. Okay. Yeah. Question.
What if you put an extra index, like specify index equals to like maybe 1 to 6?
Yeah. Let's see. I
like
think.
P series.
Let me here. Let's try this out. Okay. So basically, you want to do this, but we have the wrong value here. So So what happens? Here, we'll call this data 2. So what if I specify an extra index value, like this? Okay, so here.
I mean, like, if you scroll down, like when you're defining SAMP series, what if you specify the index to be?
Oh, in here?
Yeah.
Okay, all right. So So, okay, so here if you have a mismatch between the series values length and the index length, you get an error, and I think the opposite is also true. Yeah, okay. That's fine. So here, all right, so let's try sample dictionary. So we have the sample dictionary, so we'll call sample series 2, and you're saying specify index equal to, say, A, B, C, D. How many do I have? 1, 2, 3, 4, 5, 6, E, and F. Is that right? Is this what you're asking? Okay, let's see what happens, because I'm not 100% sure. All right. It did not like it. Okay, I mean, it did it, but it didn't like this. But maybe if I do sample.values, nope, it doesn't like that either. Okay. Okay, so you take the dictionary, and you should just make a series, and yeah, okay. Here, wait, let me see. Let me see if maybe I can do list.values here. Am I doing something wrong here? Oh, that after values, yeah, you're right. Okay, so we can do that. Let me see if I do this. Okay, so that's fine. So you can do like sample dictionary.values or is it keys? Okay, so you can use kind of the view objects to pull those values or keys out and then specify an index. But if you give it the dictionary itself, which comes with keys and values, it doesn't like that. Okay, great. Okay, so we have that sample.series. And we have this. Okay, so I wrote ages during the first Avengers film, 2012. I don't have an exact source, so these are, don't get mad at me if you're like know better, but I guess Tony Stark was age 42 in 2012, is that right? I don't know. Okay, and Thor was 1,493 years old. Okay. So here is another dictionary where I have the keys, same keys over here, and you'll notice they are in a different order, but the keys are the same. They've got the character names, and we have their fictional character ages in the movie, the 2012 Avengers. Okay, so we have that, and here is another dictionary where we're going to have their superhero name. So we have the character names and another dictionary, so we're going to have their superhero name. So we have, I guess Thor doesn't have, he's using his real name, and then everybody else kind of has a character name, okay? And so, so we'll go from there. Okay, so here I have multiple series, and with that, we can make a data frame, right? And so you'll notice these things. So here, the order of the character names, so Tony Stark, Steve Rogers, etc., these the character names are in a different order than these other dictionaries or these series that I have, okay? But when you create a data frame, you can say we're going to create columns, okay? And the column names will be actor, which is our first series. And then we have a column called hero name, and we're going to take the hero names series, and then we'll have a column for age where we take the ages series. Okay, and here it matches them up, it matches the indices, okay, and it sorts them by the index. So default is it puts the indexes in alphabetical order, and there you go. Okay. When you have a missing value in pandas, we use the nan object. All right, now nan is technically like a float, but it is allowed to be mixed with strings. Okay, and if you do that, Pandas calls this an object type data. Object is basically what we use for strings, and it allows for missing values, which are going to be represented with nan. Okay, versus over here I have integers for the age, and here it says the data type is integer. Okay, so we have that. All right, and this is the data frame object. If you ask for the type, it's a data frame. Okay, have I given you any view quiz answers yet? No. Okay, let me go ahead and give you. I'll go ahead and give you your first two, the letters C and B. I guess Clint Barton. Okay. C as in cat, B as in bear. First answer is C. Second answer is B. Are Marvel movies still popular? I've always enjoyed them, but I don't know if people are tired of these things. I watch like every series on Disney Plus. Okay. All right. Here I've got I've got a list of dictionaries. Okay, and so here I can turn this into a data frame. So here I've got A is 0, B is 0, A is 1, B is 2, A is 2, and B is 5. And so this is just another way to create a data frame, is you can give it basically a list of dictionary values, and then you say make a data frame out of this. It's going to make a column for A, a column for B, and if you don't specify an index, it'll use its default index, but here I'm going to use index 1, 2, 3. Okay, so this is what I have. And so now I get 1, 2, 3 as my index, column A and column B. Okay. Here I have a dictionary, or a list of dictionaries. I got A, B, and AC. And when you say make a data frame out of this dictionary, then Python will, or Pandas will do this, and it will say, okay, I see an A, I see a B, and then I see a C. So it's going to have a column for A, a column for B, and a column for C. And then where it doesn't have values, it's going to put in NAs. Right? Yeah.
Why does this one get like a fancy table?
Yeah, so there is a difference. So over here I call print. So when you call print on a data frame, it prints it out in fixed width text. And when you don't call print and you just have it return the data frame, then Jupyter formats it into kind of like a nice little HTML table. So a lot of times I'm not going to use print, and I'll just do it in this, the thing. But that's the difference. So when you call print, it, puts out, fixed width text onto the screen, which if you're running like a script, that's great. But if you're using a notebook, then Jupyter has kind of these nice little features that just allow for, some of this stuff here. Okay, but I think this is, I imagine this is what we would have expected to happen if we have A, B, and C, and we don't have values for C, and we don't have value for B at index 2 or something like that. Okay. If you have multiple kind of things, you can take a dictionary. So this is another way to have a dictionary and turn it into a data frame. So you can have basically column A, and here's a list of values. Here's column B and a list of values. And we can say, all right, so here's my dictionary, and make a data frame out of this. And Pandas does exactly what we expect. All right. If you give it arrays that are not the same length, so I've got 1, 2, 3, 4 for A, and XYZ for B, okay? Then it runs and it says, I can't do it, okay? It says all arrays must be of the same length, okay? And then I think that also makes sense. And then another thing you can do is you can take a matrix, or I guess a two-dimensional array, and you can make a data frame out of the array. And here I'm specifying the column names and the index. If I just do pd.dataframe on data here, it will default to just using a range index for the rows and range index for the columns as well. Okay. All right. So how do we work with the data frame? Okay. Well, one is we can subset, and basically, if you ask for the columns, it'll give you the column names. We got actor, hero name, and age. If you ask for the index, it gives you the row names, and you can use dot notation to just get one column. So here I can do dot actor, and we will get that one column. It's a series. It comes out as a series, so it still prints out the row names. Yeah.
If data frames are part of the pandas package, how do you want to do pd.avengers.column?
Okay, so Avengers is a data frame object. So
Like already exists.
So it exists. So the fact that this thing exists means basically all of the pandas associated, or the data frame associated methods are there, right? So kind of like in base Python, you can create a list, and you can call any list methods like list dot, the thing. So if you have a list called people, you would do people.pop, and you don't do like list.people.pop or something like that. So that object name comes with all of the methods associated with that object type. So Avengers itself is a data frame object, and so it comes with all of its methods. The data frames get attributes equal to the column names as well. Okay. If you have a space in the column name, then you'll have to use square bracket notation to kind of get it. So general recommendation would be not to put spaces in your column names, but sometimes you import a thing and there's going to be spaces and stuff. Okay. They are when you select a column, they are going to be series, and you can kind of pull them out accordingly. So you can do zero-based indexing. So here, because the index uses the character name, index 1 will be Clint Barton here. You can also use Boolean vectors. So here I can say who has age equal to 42, and apparently there were two characters, Bruce Banner and Tony Stark, are the same age in the movie. Maybe, I don't know. I'm not an expert on this. And so we have that. Okay, and you can take one of these columns and extract out the value associated with it, or you can also use colon to get everything in between those things. So these are how you can subset this. There is probably the way you're going to extract values from a data frame is there's two methods. There's the .loc and the .iloc, okay? The .loc for basically the locator uses index names, okay? So here, if you do Avengers.location, and so one thing is the .loc uses square brackets, and a common mistake is students use like parentheses because we're accustomed to using parentheses for a lot of these things, but .loc uses square brackets, and it uses it's going to pull the row. Okay, so it feels a little bit strange, but if you look at Avengers itself, right? So for Thor, the row says, Chris Hemsworth, NA, Nan, and 1493 for his age. So .loc is going to pull out that thing. Okay, and so here you get a series technically of different data types, but this is it's a structured series. Okay, the type is series, and then the values in here are in a NumPy array, and it's a mixed data type. And we felt like, oh, I thought NumPy arrays can only have the same data type, and that's generally true. There is an exception for what we call a structured NumPy array. And a structured NumPy array basically says in the first position, it's always going to be, string type. In the second position, it's always going to be string type. And the third position will always be an integer. And NumPy does allow for structured arrays if it's always going to have that certain kind of structure in there. I would say it's less commonly used. Like, people don't generally directly create structured NumPy arrays, but it's almost like a side effect of using Pandas data frames. You're going to get these structured NumPy arrays when you pull out rows. Okay. So anyway, you can do .loc, and you can give it a column name, so like age, and then you would use a single colon to say I want all of the rows, and it will pull out that column. And again, this is a series, and the internal values are arrays. And then again, if you want to kind of specify a coordinate, you want row for Steve Rogers and the column for age, or whatever, you get the value there. Okay. .iloc uses the index location. Okay, so zero-based index location. So you can say I want index 3. Row index 3, and that is 0, 1, 2, 3. Steve Rogers, and you get Chris Evans, Captain America 104, and that's what you have. Here you can do a pair of coordinates. So this will be row 0, index 1. Row 0, index 1 will be Hulk, I think. Yep. You can use assignment with iloc or loc. So here I can do Thor's age, we're going to reassign to 1500, and then we'll say Thor's hero name will be Thor, not missing. And so so we have this now. So Thor is Thor, age 1500 or something. Okay. You can also assign multiple values at once by kind of using the .location and subsetting. So here I've got Avengers .location, so row index Thor, and then we'll do hero name and age, and we're going to assign back Nan in 1493, and we can do that, and we can do that as well. Okay, so you can imagine making this more complicated with more conditional assignment type of things. Okay. So here is an example where I have a data frame, and for the indexes, and the index is the integers 1, 2, 3, okay, but it's not 0 indexed, okay? So when I use .loc always uses the actual index. So .location 1 will pull out this row associated with index 1, 11, 2, okay? Whereas .iloc always uses a zero-based index location, okay? So iloc 1 says, this is row 0, row 1, row 2, so row 1 will be the 12, 4, okay? I want to make sure this makes sense. The difference between .loc and .iloc, it can get confusing if your indexes are integers that don't start with 0, okay? Because these things look similar, but their behaviors are very different, okay? And so if I say .iloc 3, which doesn't exist, right? .iloc 3, zero-based index location 3 expects a 4th row, and that doesn't exist. This is going to return basically a key error, I think, or no, index error, okay? It says positional index is out of bounds, right? Because it goes beyond the boundaries of the table, right? So I would say this is when you start off with pandas, this is an early source of errors, is mixing up .loc, .iloc, and mixing up these things. Also, especially if you're accustomed to R being 1 indexed versus Python being 0 indexed, that's often a source of confusion. And I get thrown off all the time. And I often catch myself using the arrow assignment operator in Python, and I'm like, oh no, I can't do that. So it's just bilingual problems, right? When you're trying to work in different languages. Okay, so you can use Boolean subsetting with .loc, okay? And so here, if you want to say, I want to find everybody whose age is between 40 and 50, so you can do avengers.loc, and you say, which rows do I want? The rows I want are where avengers.age is less than 50 and avengers age is greater than 40. And we want to get the hero name and their age, and we get that, okay? Apparently 41 and 42 is superhero age. I don't know. I'm just trying to think. How many years apart was Endgame? Or like how old were Clint Barton kids during the first Avengers? We don't know. Okay, well anyway, that's like a main impetus of his storyline in Endgame, right? Okay. So anyway, you can do this, and so Python can get a little bit confusing because we have the ampersand operator and we have the and operator, right? So when you're working inside, say, if you're using like NumPy arrays and you want to kind of have these conditional things in there, you'll be using the ampersand and the kind of the vertical line for the bitwise and an or. So you basically, this produces an array of true false values, and this also produces an array of true false values. And you want to kind of, if you have multiple arrays and you want to kind of do operators with them, this is when you'll use the and, okay, the ampersand, okay, versus the and is generally used for single values, okay, single true, single false type of things, like in if statements. So here, let me just show you what happens if I type an and here. It says it doesn't like this. Okay, okay. So here's and if I do or, I think this will give everybody, right? If you have a less than 50 or greater than 40, that's basically from negative infinity to positive infinity. So so that's what we'll have. This is the exclusive or. So basically this is everybody but. So it's either you're less than 50 exclusively or you're over 40. We don't want anybody in between. Okay. All right. So if we have that, you can also take the index. So here I'm chaining several methods. Okay. So here, let me just show you what each of these things do. I've got avengers.index. So this gives me this, and if I do index.str, this converts it to, this converts it, why doesn't it like it? It can, basically it converts it to a string, but, okay, well, you can do avengers.index.string, so .str will kind of give it you string accessible methods, and so here I can say starts with B. So if I copy this, all right, now we'll get a vector for true, which ones. right? So we have Bruce Banner. I guess that's the only one that's true here, okay? And so if we do that, we will get that particular row, all right? And so you have, multiple things here. So here, I'm going to do avengers.indexString.find, capital R, okay? And remember, what does find do? So if you call find on a thing, it's going to give you -1 if it doesn't find it, and it gives you the index value if it does find it. So here we have, I think, Steve Rogers and Natasha Romanoff here, and here we're saying we want anything where it's not equal to -1, right? So here will give me characters who have a capital R in their name. Right. So this is you can make your statements as complicated as you want using the .loc thing to find particular rows. Other things you can do: you can transpose a data frame if you want. You can ask basically what are the data types in the data frame, and then you can also ask for the shape or the dimensions. Okay, how many rows, how many columns. All right, and then the last thing, if you have some CSV file, you can give it the location. So you can give it like the location on your local disk, right? So on your local hard drive, if you have Titanic.csv, you can do Titanic.csv. If you know if the data set exists somewhere on the internet, you can give it a web address and it will just read it in. So a lot of times there's just files directly available on, say, GitHub, and you can just read it in directly from the URL. So this will work. Okay, read.csv. It's if you do pd for pandas.read_csv, and it will read it in. So there you go. And so here is the data frame. It says 891 rows, 11 columns. And so one of the columns is passenger ID, which is 1 indexed. And then by default, because we didn't specify an index, it adds a range 0 index thing. I think you can specify index is equal to, I don't remember. Oh, I didn't like that. Passenger ID is not defined. Okay. I'm going to ask for help on this. How do you specify index? Oh, index column. That's what it is. Index underscore column, I think. That seemed to have worked. Oh no. Oh wait, yeah. Okay, it did. So if you want to specify an index, you can do index underscore column for which one it is, right? But by default, it's going to just add a range index to your thing. Okay, the shape here. Well, now I only have 10 columns versus here. Let me re-import this without specifying the index, and so it's going to add the index, and now we have 11 columns, and now the shape is 891 by 11. We can ask what are the column names. So passenger ID is one of the column names versus an index, and again, that's an option that you can use under read_csv. And here the index, it's the default range index, okay. And then there's more things that you can do, such as .info. .info will give you, basically, this is like your equivalent of the structure. In R, you have str, which kind of gives you the structure of this thing. .info is basically a very similar function, and it tells you, okay, which column number we're looking at. This is the name of the column, and it tells you how many values are not missing. All right, and so, you know, by default, if it doesn't see anything, it'll kind of give you a nan object, and then it'll tell you what data type you have. So you've got ints, and over here, so notice age. So inside the data frame, the ages are integers. Everyone's going to have a .0, but because we have some missing values, it's going to insert nans for those missing values. And if you have a numeric thing and you have nans, it's going to convert those things or upcast them into floats, right? Because a nan is there's no nan for an integer. So nan is always a float. So if you put a nan inside a thing of integers, it's going to upcast all the integers into floats. Okay. Whereas as far as survived and passenger class, there were no missing values, so those can remain integers. Anything else here? Okay, so ticket, this is text, and fare has decimal values, so those are going to be floats. And then cabin, some people had missing values, and so you have nan. And embarked, I guess, is a string value, is where they got on, and I guess we knew everybody but 2. I don't know, and that's what we have. So Titanic.info. And then .describe is for the ones that are numeric. It calculates kind of your count and your mean and your min, your 5-number summary as well as the mean and standard deviation. So you'll get your min and your max and things like that. And it'll do this for anything that's numeric. Okay, and these are all it throws away the nans. So that's kind of the default behavior there. Okay, that's kind of just an introduction to pandas, and we're going to be using pandas quite a bit, so we'll start there. Okay, that's it for today. Have a great weekend, and we'll see you on Monday. Yeah, question? Oh, you're right. I need to give you your last viewpoint answer. Last viewpoint answer is E. E as in elephant. E as in elephant. Okay, thank you. All right, have a great weekend. We'll see you Monday.